Hello again, grade 12s. The question we'll be looking at today is from exercise 6.5, number 8 of your Clever Maths textbook. The question we're looking at is 8 sine squared x plus sine 2x minus cos squared x is equal to 0. So with this type of question, the first thing you look at is what have they given us and what am I meant to do? They want us to find the general solution and solve for x within the range minus 180 degrees up to 180 degrees, including both minus 180 and positive 180. So the first thing that you look at here is the sine 2x, right? This represents one of our double angle formulas, and immediately we can rewrite our question so that it reads as follows. 8 sine squared x plus 2 sine x cos x minus cos squared x being equal to 0. Now that I've done that, I'm going to make my life a little bit easier. You don't have to do this, but this just helps you to see exactly that you have a trinomial here that you can factorize. I then say let a equal to sine x and let b equal to cos x. Then you substitute that into your equation. Your equation will now read as follows: 8a squared plus 2ab minus b squared, all being equal to 0. So immediately we can call on our skills from grade 9 and 10, and we can factorize this trinomial into two brackets. So start off with your b squared. We know that the factors of the b squared will just be b and b. It's a negative b squared, so we know that one will be negative, the other one will be positive. We then look at the factors of 8a squared. You have several options here. You could either select 8a and a, but when you multiply those out, you won't get your original equation. If I employ or use 4a and 2a there, okay, and multiply out, that's when I will be able to get my original equation. So now we know from the zero product principle that either 4a minus b is going to be equal to 0, or 2a plus b will be equal to 0. We can then solve from here, isolating variables on either side of the equation. 4a will be equal to b, or 2a equals minus b. Right. From there, I can now substitute back my trig ratios. I will have 4 sine x equals cos x, or 2 sine x equals cos x. Right. I can further simplify these two equations by dividing by cos x both sides, right? If I divide by cos x here and cos x there, right, this then simplifies to 4 tan x is equal to 1. We are going to do the same thing for the other equation. Divide both sides by cos x and cos x here. Remember, sorry, there's a negative sign here. So we divide both sides. We're left with 2 tan x is equal to negative 1. Okay, now the next step would be to divide both sides by your 4 for this one and divide both sides here by 2. So you're at this point where you now have tan x is equal to a quarter, or tan x is equal to negative a half. We now want to find what our general solutions are going to be. So from here on out, we're trying to solve for the general solution. General solution will be as follows. Inverse tan both sides. X equals tan inverse a quarter plus 180 k, again k being an integer. I will call that equation 1. Equation 2, same process. Inverse tan both sides, negative half plus 180 k, k being an integer. We can further simplify both equation 1 and equation 2 so that we have 14 degrees plus 180 k. Okay, so don't forget your degree signs there. K being an integer. Then for equation 2, this becomes minus 26.6 degrees plus 180 k, k being an integer. So these are your two general solutions, right? Now for this question, they wanted us to solve for x within the range minus 180 degrees and 180 degrees. So again, the process that I use here, I'm going to then sub k equals 0 into both equation 1 and equation 2. X equals 14 plus 180 multiplied by 0. This leaves me with just 14 degrees. Is this 14 degrees within this range here? Yes, it is. Okay, so this is a valid answer. Then, equation 2, we're doing the same thing. We are subbing 0 where I see k. Minus 26.6 will be our answer. Is minus 26.6 within the range? Yes, it is. So we use that answer as well. Now the next step I'm going to sub in k equals 1 into both equation 1 and equation 2. Again, where I see k, I'm substituting in 1, okay, in both the equations. So my answer here is going to be 194. Is 194 within our range? No, it's outside the 180, so we won't use that value. Then for the other one, the answer is 153.4 degrees. Is this within our range? Yes, it is. Okay, so we use that answer as well. So what I'm going to do now is then sub for k equals minus 1 into both your equations. Same process. Where I see k, I substitute in negative 1. Okay, so the reason we're doing this, okay, is to make sure we get all or as many of the values within that range. Okay, so your answers for these two are as follows. For this x here, we get minus 166 degrees. For the second equation, minus 206.6 degrees. Okay, let's evaluate our answers. Minus 166, is it within our range? Yes, it is. Minus 206.6, is that within the range? No, it's not. So we see that we have 1, 2, 3, 4 valid answers. Okay, so the x values are as follows. I'm going to write them in ascending order. Sorry. Okay. Sometimes you can also express, or you'll see the answer expressed in set notation. Okay, so either one of these is acceptable. Okay. That is our answer, and we have solved for x within the given range. Okay, I hope that makes sense.